Hi, now if you look at the main.py, so main.py is having a very clean code. It is containing what should be with this, what should be done with the screen setup and all. And then there are event results which are added for every event. And then we are going to move the snake and just create a snake object and move the snake is what is happening here. Now, if you look at snake file, so everything related to snake is here. So, if you look at this, everything related to snake is here. Go to main. In the main, go to imports. So, here if you see it, the turtle is in gray. We are not using the turtle object in the main for main.py. Turtle object is used in snake.py. So, we can delete it. Okay. So now let's try to do one thing. Let's try to work with the food. So we are going to put food on the screen, and whenever our snake touches the screen or touches the food, it should actually disappear and appear at a different place. So this is what we want to do. Now we want a new turtle to create the food. Now food is a small dot, a blue dot. You can use any color you want, a small dot, and now that dot has to appear on the screen randomly at any position, and then when you try to touch it, it has to disappear. And later we will see how to increase the size of the snake. Okay, first now focus on food. Let's now create a file called food.py, and now instead of, even though food is actually an object, can be written as an object of turtle class, let's not do that. Let's try to use inheritance here. Okay, so first try to import turtle class, and then let's try to make food object for food class inherit turtle class. It is actually not required. You can also do it without inheritance, but I want you to practice inheritance. That is why I am doing this with inheritance. Now, food is a class which is inheriting from turtle class. Now you know what should happen. So you have to write an init, and then you have to call super.init in the init. So this is what is going to happen. So init and then super.init. Now food has all the methods and attributes of the turtle class. You can directly use them. Okay, without creating an object, you can directly use all the methods and attributes of turtle. So now we are going to specify shape. Shape is a method which is present in the turtle class. Now that we are inheriting turtle class, we can directly use shape. Self.shape you can write. Actually, shape is not present in food class. Shape is present in the turtle class. So what I want to do is, I want to make it as a circle. I want to make the food as a circle. That is why shape I am putting it as circle. And then I don't want a line to be drawn whenever a circle is created somewhere in the screen. I don't want a line to be created when it starts from the origin and it will come to the position. I don't want that line. That is why I am doing pen up. So food doesn't have pen down. It has to be always pen up. And then the shape of the circle can be modified using shape size of the turtle object. Now the shape of the circle is 20 by 20. I want to make it half, 10 by 10. That is why I am putting 0.5 and 0.5. So stretch length and stretch width is going to multiply it with the actual size and get the final size. So if it is 20, it is going to be 10. So again, you can read the documentation about all these methods. By reading the documentation only, I came to know about these methods. Okay. And now set the color to blue. So color is set to blue. So you can use any color you want. You can use red or yellow or any color so that it will be visible. We have used blue. You can use anything. And now the speed is set to fastest. Now why do I need the speed to be fastest is, whenever a turtle is created, it is always created at the center of the screen and it will move to a random location. Gradually it will move. Right? But we don't want that gradual movement. We want it as if it is appearing on the random position right away. We don't want it to move from the origin to the random location. That is why we are using fastest. Now we want it to go to a random location. Whenever a food is created on the screen, it has to go to a random location. For that we are using go to. Now we are going to create random location by taking random x and random y. So now the screen is 600 by 600, which means on the x-axis it will go from minus 300 to 300, and on the y-axis it will go from minus 300 to 300. So I want a number between minus 300 and plus 300 in both x-axis and y-axis. But the problem is, if I go till 300, it will be very difficult for the snake to eat the food which is touching the edge. It is very difficult, and we cannot play like that. That is why we are using 280. So instead of 300 to 300, you know the screen size is 300 by 300, I mean 600 by 600, right? So we are going from minus 280 to 280. We will generate a random x and random y. And then go to will. Now what happens is, whenever I create the food object, init will already init will be called, and all these lines will execute without you doing anything. You don't have to do anything. All these lines will get executed. Now let's try to go to the main.py and create the object. Let's import food class first. Let's import the food class, and now let's try to call it. Immediately after snake is created, we are going to create food also. Now when you call it, all the methods in the init will be called, and automatically you will see a blue dot on the screen. Let's try to run it and see. Now you can see that there is a blue dot, right? It is randomly created. Now we have to see how to see whether it is colliding with the snake. So with the snake dot head, it has to collide. So there is a method called distance. So we are going to check if snake has collided with the food. That is important. Then only you will know what to do next. So we are going to detect the collision. So there is a method called as distance. If we are taking the snake dot head, which is a turtle, you know that head is a turtle, which is a segment and a turtle. Now we are calling a distance method on it, and distance is a method available on turtle. You can read the documentation, and in the distance I am passing a parameter, a second turtle. So we are taking the first turtle and we are passing some turtle to the distance method. Now it will give the distance between both the turtles, right? Now if the distance is, you can say, less than 15. So by experimenting, I found out that 15 is a very good number to work with in this game. You can experiment with 10, 5 or 0 or whatever. So whenever they are close, you can experiment with them. Now if it is the case, then there is a collision. I am just writing collided. Now if I run it, if I go near it, if I touch it, it is difficult to touch this one. Yeah, we have touched it, and you see that there is collided. Again, if you touch it one more time, I think it is difficult. Yeah, again it is saying collided, right? So whenever you touch it, it is saying collided. Now we have to see, instead of putting collided, you have to see what has to be done. So we have to, again, once the food is collided, then you have to create a new food somewhere. So for that, we have to use these lines, this randomly generating a new location, and then our turtle has to go there. For that, what we will do is, we will remove these lines and create a new function called refresh, a new method called refresh, and inside the refresh I am putting it Now every time it happens, collision happens, we are going to do refresh. So it is going to a new location. I think when you create the food, again refresh has to be called. Just check it. When you create the food object, yeah, here we are going to call refresh. So initially when you create the food object, then automatically refresh is going to be called, and automatically at a random position we are going to put the food, and whenever there is any collision, again refresh is called, and again we are going to put the food at the random position. So that is the purpose of refresh. Go to main ones. Now if you observe it, whenever there is a collision, we are measuring the collision like this, and the refresh is called. Run it once again. So initially it is at a random position, and now when there is a collision, again it is changing its location, and again there is a collision, it is changing its location, right? So far we have done that. Now we will go to the next steps. Okay. Now, in our game, we want to show the score to the user. How many food items he has eaten, okay? How many points he has got. We want to show that as a score. Now, how are we going to show this as a score is again by using turtle. So, using turtle, there is a method called write. If you go to the documentation of turtle, there is a method called write, and this method is going to take as an argument arg. So, first argument is nothing but what has to be written to the turtle scheme, that has to be given as the first argument, and then move do you want to move the text, or you have to have the same location, that is going to be at the move, and then align, do you want it to be at the left of the screen, center of the screen, right of the screen, that is going to be the align, and then the font, what is the font that you want to write it. So whether you want to write it in Arial, and size has to be 8, or normal, bold, or whatever you want to write. And now if you see it, font is actually a tuple of 3 values. You have to be careful there. So now using this write, we are going to write something onto the screen, and we are going to show the score. Now let's go to the program. Now let's create a new file called score. Let's create a new file, scoreboard. So now scoreboard.py is created. Again, we will use inheritance. So now let us say our score class is going to inherit from the turtle class, so that it will get all the attributes and methods of the turtle. You don't have to call them from the object. You can directly call in the init. So we are going to have a scoreboard class. Now this scoreboard class is going to inherit turtle class. So we are going to write turtle, and now in the init you have to call the turtles init by calling super, or you can directly use turtle class name and you can call the init of the super class. And then initially the score is initialized to 0, so initial value of score is 0. Now let's try to call the write method. Let's try to write some f string as the first argument. What has to be written, that is score is initially 0 value, so that is present in the score attribute, and then we have to say what is the alignment. So we are using keyword arguments here. so that it will be, see, always try to use the keyword arguments as much as possible so that it will be readable. If I directly write center, people who are reading it will not understand it. If I write align equal to center, you will understand, oh, it is alignment. Now I want it at the center, and the font, go to the next line. So the font we are using is Arial, and the size we are using is 24, and then we are using a normal text. So let's try to run it and see whether the score is printed or not. We have to import it first. From scoreboard, import scoreboard class. And now after creating snake and food, let's create the turtle scoreboard. Now let's try to run it and see. Now there is a problem. We are not seeing anything on the screen. The reason is our screen is black and the font color is black. So we have to change the turtle color to white, or any color you want. Let's keep it white. So now let's go to the scoreboard turtle, and the scoreboard turtle has to be having color as black. But if you write like this, it will have no effect. Color as white. If you write like this, it will have no effect, because after it is written, we are changing the color. So if you have to, again, there is no effect, right? So there is a turtle symbol there is an arrow symbol, but it is showing no effect. So we have to put the color above writing. Now if you see this, score is given, and now if you observe it, there is an arrow symbol which is actually the turtle that is also being shown. We don't want that arrow symbol, and also I want to move score to top, not here, not at the center. We can use go to. We know that the size of the screen is 600 by 600, which means if we have to go to the top, y-axis has to be 300. But if I write 300, the font will go out of the screen. Let's write somewhere around 270, 280. 270 will work. So again the problem is we have written that line after printing the score. We have to write that line above it. Write the go to above the line. Now if you run it, now it is above there, so everything is fine, but only thing is you are able to see a line here. This is because by default for a turtle, pen is down, which will be in the drawing state, but you have to do pen up. So let's try to do pen up. Now run it. Now everything is fine, but there is an arrow symbol here. So that is actually the turtle symbol. By default, arrow is the turtle symbol. Now we have to hide it. There is a method called hide in the documentation, using which you can hide the turtle. Now you can see that the turtle is hidden, and you can see the score. Now let's try to increase the score or keep track of the score instead of having it 0 all the time. Whenever our snake touches the food, we want to increase the score. So where are we going to see that? So let's say we are writing a new method called increase score, and we will call this increase score whenever there is a collision. So we are writing it in the scoreboard file inside the scoreboard class. So every time when something whenever there is a collision, we want to increase it. So let's go to, and whenever we are increasing the score, we are printing it. We are writing it on the screen. So increase it and write it on the screen. Now in the main.py, whenever we detect a collision, for example, here there is a collision with the food in the if condition. There we are trying to increase the score. Now let's try to see what happens. Now there is a collision. Now you can see that something is happening here. You can see that, again collide with it one more time. It is difficult. We have to practice it. Okay, try to collect. Our TA is, yeah. Now again you can see that something is happening here, but it is not very clear what is happening. So what exactly is happening is the score is increased and the score is actually overwritten on the old score. So we don't want that to happen. We want to clear the old score and write the new one. So now let's try to see that. See, if you observe it, 1 minute, hold it. If you observe it, right is here and right is here. The same line is repeating 2 times. Now, instead of writing it separately 2 times, we could actually put it in one method and we can call that method whenever it is required. Okay. So, there we can also write clear. So, the same right is there at two places. Whenever you see such thing, write a function for it. It will be readable. Now we are calling it. Earlier, wherever that line was, now we are calling it update score. And also, here also you can delete this line. And you can call update score. Now, before you update the score, try to clear the score so that it will be visible, clearly visible. Self.clear. Now if you run it, you can see that score is getting updated and it is visible now. See 1, 2 like that. And one more time. It missed. It missed again. One last time. Yeah. So now it is 3. So like this, the score will keep on getting updated. Now in the next video, we will see how to detect the collision with the wall. So what I mean to say is, let's collide with the wall. Let's see what happens. So it is colliding with the wall, and again it will come back. If you try to use some keyword, it will come back. This is not what we want. Whenever it collides with the wall, we want to stop it. We will see that in the next class. Okay. Hi. So now we have to detect the collision with the wall. There is a small problem with the game. So when you collided with the wall, it is actually passing through it, and then we are getting a notification that it has collided. So we don't want that to happen. We want to collide with the wall if it reaches the boundary. So what we want to have is, we are creating a boundary across the wall, something like this. So we are not going till the 300 or minus 300 positions to understand that there is a collision. We are going to stop at minus 280, or you can experiment it. See, in any game, what happens is you have to experiment it and then see the values. The values may sometimes be different. Okay, so you experiment with your game and see which values will work for you, so that while seeing the snake, it should be shown as yes, it has hit the wall. It should not cross the wall. So for that reason, we are stopping the game when the snake has come to minus 280 or plus 280 on all the sides. Okay. Now before going ahead, Let's try to do a small modification here. If you observe here, align is there saying center and font is there saying some constants. So whenever there are constants like this, it is better to have constants in the file and put it. So this is happening in scoreboard class. Now we have align and font. So for both of them, we are creating some constants here for align and font, and we will use those constants so that it will be easy if you later want to change it. When you type it, hardcore it in a function call, it will be difficult for you to find it and change it. It will be easy for you to change it. So font and align are taken. Now here in the align, I am going to put alignment, and in the font, I am going to put font. Okay, now let's get back to the problem. So now how are you going to detect whether there is a collision? So we'll go to main.py, and in main.py, if we'll write one more if condition, just like how we have detected collision with the food, now we are detecting collision with the wall. So we are going to use -270, -280 range, those values, so that it will be easy to understand that there is a collision. I will show you with the after I run the program, I'll show you what happens. Now we are taking the head of the snake, which is a segment, which is a turtle, and we are getting its x coordinate by using xcor. It is a method in the documentation, you can check it once. It is a method available on turtle. And now if it is greater than 280, which means it has passed 280, or we have to check 4 conditions for x and y, both the sides. So we have to check 4 conditions here. Or if it is less than -280, which means it has passed 280, or y coordinate, y coordinate is greater than 280 or less than this. Now if it happens, we want to stop the game, or there is an error, try to put them in one line, no problem. Okay, so now if it happens, if all the 4 coordinates are like that, then we are going to take that game is on variable, move up and show game is on. Here we are using game is on for the while loop, right? So game is on is true always, which means it will continuously happen as long as this variable is true. Now we are going to make it false so that we will stop the game. We will stop the snake from moving. Now let's run it. Now if you observe it, when it has touched the wall, the game has stopped. So I want you to see what happens if we have used 300 or what happens if we have used 270. For me, in the experimentation, I found out that 280 is a better number. You find out your own number. Now, one more thing that I want to show is that whenever the game has stopped, it doesn't look good if it stops like this. It has to show game over text. For that, we are going to again go to the scoreboard class. That scoreboard is actually we are using scoreboard to write the text. So again, instead of creating one more turtle, you can use the same one. So in the scoreboard class, we are writing one more method called game over. Now game over is going to say it is going to write that game is over. But then there is a small problem with it. So let's try to run it and see once. Make the game over. So there is a small problem with it. So let's try to fix it. So we have to go to the center of the screen by going to 0 0, and let's call it. If you don't write 0 0, it will be printed at the top only, the alignment and all are at the top. Now let's try to run it. You can see that game over is overwritten on the score, right? So we want it to be in the center. That is why we are using 0 0 here. Now we will get it in the center. Yeah, so this is what we wanted. Okay, so finally, whenever there is a collision with the wall, we are stopping the game. Now we have to even check the collision with the body. Sometimes a snake will grow very large in size. We are not going to play the game till that point. But when it grows very big, and again when it loops back into its body, it has to stop. We'll see that. Okay. So we forgot to do one thing. Whenever the snake eats the food, its length has to be increased by one segment, right? So we didn't do that. Now in this video we will do that, and also we'll detect the collision with the tail. So before that, I want to explain you the code that we have written earlier in the snake class. In the snake class, there is a create snake method in which I am creating the segments one by one, and I am adding them in their positions. So first one is at 0 0, next one is at minus 20 0, and next one is at minus 40 0. So that is actually in the starting position. Show the starting positions there. Starting positions are 0 0, minus 20 0, minus 40 0. These are the positions into which we have created each segment and added them one after the other so that they look like a snake. Now if you have to add one more segment, where are you going to add it? So it has to be added at the end. Now how do you know the ending? Ending is nothing but in this list of segments, whatever is there, this new segment is there, no? So sorry, segments is there. Segments is the list of segments that we have accumulated so far. Now go into that segments and go to the last one, the last segment, and take its position, and in its position you put the next one. See, already snake is there and it is moving. Now in the last one, if you put the newly added segment, then it will look like it is growing, snake is growing, right? It actually, we are placing a segment at the end that looks like snake is growing. Now let's try to see that. So first we have to detect. So now the same code which has added the segment, we are using the same code to add a new segment. So instead of having this using the same code two times, let us call a try method. Let us create a method and put this code of adding a segment into the snake. Put that code in there. And let's call that code. Now to this code you have to send what is the position where you want to add it, because position is used here, right? So position, and now let's call this in the create snake method. Add segments, and let's give it the position. Now at that position it is going to be added. Now if you have to add a new segment to the snake, again you have to give a position. For that we will write one more method. Let's call it as extend. And now the extend is going to take the position of the last segment available in the segments, and it is going to pass that position to this method, and it is going to create a new segment and add it to the segments list. Okay. Now we are taking the position of the last segment. How do I get the last segment in a list? -1. In a list, if you have items, how do you get the last item? By using -1. And you are taking the position of the last one, and we are passing it to the add segment. Now we are calling the add segment. Now add segment will create a new segment and it will add it to the last position and it will append it to the list of the segments so far created. Okay. Now where are we going to call that extend? Whenever there is a collision with the food. So this is the if condition which is checking collision with the food. Here we are going to call it snake.extend. Whenever there is collision, we are extending the snake. Now let's try to run it and see. So there is food there. We can see that the size has increased. Are you able to observe it? Okay, game is over because it is difficult to eat it at the end. You have to practice it. Run it one more time. It is easy. And there it is. You can see that the size of the snake is growing. Are you able to see that? The size of the snake is growing. Okay, stop it. Now we want to detect the collision with the snake body. If the head of the snake collides with the snake body, we want to stop the game and say game over. We have to write a for loop for that. We want to detect the collision with the tail. Tail means the entire body, you can think of it. Tail means not the last one, it is the entire body. Now, we are going to take the head of the snake and we are going to compute the distance with and all the other segments in the body. We are taking the first segment, which is head. So this is all the segments. These are all the segments which are present in the snake so far. And we are taking the head and we are computing the distance with each one of the segments. We are taking the head. These are all the segments available in the snake. We are taking each segment one by one and computing the distance with the head. And if it is less than 10, this number you have to play with. We have found out that 10 is a good number. You have to play with the number, okay? So that whatever looks good in your game. If it is the case, we are going to say game on is false, and we have to call the game on sequence on the scoreboard. Game over. So you have to print the game over. So that is why we are doing it. Let's try to run it. There is a problem here. We got game over right away. So can you understand or can you figure out what might have gone wrong in the code? Just show the code. See this. We are taking all the segments in the snake one by one and we are computing the distance with the head of the snake. And if the distance is less than 10, we are stopping the game. But there is a problem in this code. Can you figure it out? Well, the problem is head is also present in the list. So you are computing the distance with head and head again. So the first segment in the list is head. Now you are computing the distance with the head. And you are saying that if it is less than 10, you come. So distance between the head and head will be 0. And so it is always true. So you have to change it. You should not compare with the head because head cannot be compared with head. You have to compare it with the other segments. For that reason, if this segment equal to snake.head, which means the current segment that we are examining is equal to snake.head, we don't want to do anything. We want to pass. Elif, we are going to check the condition. Now we can check the condition and we will see. Try to collide with the tail if possible. It is difficult, I guess. Okay, we are wasting time. So you play the game. Okay, you play the game and make the snake very big and try to collide with the body of the snake and see that it stops. The game gets over. Okay. So that is the end of the game. Thank you.